Hello everyone, I hope you are doing well. In this video we'll learn about the core foundation of RAG system, that is document processing. I'm already assuming that some of you may have experience with RAG, LangChain and Python, but even if you don't have, that's completely fine. By the end of the video you will have a complete understanding of how to build a pipeline that converts complex PDF into LLM friendly Markdown file. Also, big thanks to Dockling, a free and open source library by IBM. I'm using it in my current PDF processing pipeline. A quick disclaimer, this video is not focused on coding line by line, but the main goal here is to understand the overall architecture and flow of the system. I share GitHub link so that you can explore code later and understand it step by step by using ChatGPT or any other AI tools. So with that said, let's get started. Now let's understand how RAG works. Let's start with the raw data like PDFs or text files. First, the data is processed and cleaned. Then it is broken into smaller meaningful chunks using any chunking strategy. These chunks are converted into vectors using embedding model, and it is stored in vector database. When a user asks a question, that query is also vectorized, and the database retrieves the most relevant chunks using similarity search. Finally, the retrieved context and the user query are passed to LLM, which generates the final response. For now, we'll focus only on the document processing stage, specifically how we handle PDF documents. So the challenge with the PDF is that they don't just contain text. They can also have tables, formulas, equations, diagrams. So let's see how we can handle these different types of content. So here we have table with 3 columns: name, subject and marks. For example, Arjun has scored 60 in math. Now if you directly send the table values like Arjun math 60 to embedding model, the relationship between the field is not very clear. So the vector may capture the words, but the meaning between them can get lost. So instead we convert each row into natural sentences like Arjun has scored 60 in math and Karthik has scored 90 in math. This way embedding model captures the complete semantic meaning, which improves retrieval when vector database performs similarity search. Formulas in PDFs are often most difficult for embedding models to vectorize it directly. So we convert them into LaTeX, which is a structured text format used to represent mathematical equation. Along with that, we also add a short explanation of the formula, so the embedding model captures the complete semantic meaning. PDFs often contains diagrams and images which text embedding models cannot understand directly. So we generate a detailed caption and description for each images. This converts visual information into text, making it visible for embedding and retrieval. To summarize, images and diagrams become description, tables become structured summaries, and formulas become LaTeX with explanation. To generate these, we use Vision LLM like GPT-5, which can understand visual content in the PDF and convert it into meaningful text. Now I am here inside VS Code and the main file is docbrowser.py. This file contains a core logic for converting a PDF into Markdown file. In the main notebook, I am importing a function from docbrowser.py and passing the path of sample PDF. The sample PDF I am using is attention is all you need because it contains almost everything: text, tables, formulas, images and diagrams. So it's a very good document for testing this pipeline. I have already executed the code because it takes around 5 minutes to generate all the outputs. Once it runs, everything gets saved inside the docasset folder. You can see separate folder for formula, extracted images, page-wise markdown files and tables. Now one important thing here is that the PDF is processed page by page and each page is converted into an individual markdown file inside pages MD folder. The reason we do this is to avoid memory issue, especially when working with larger PDF. If we try to load and process the entire PDF at once, it can consume a lot of memory and the pipeline may fail. So processing it page by page makes the pipeline much more stable and scalable. Finally, we also generate processed doc.md, which combines the full content of the PDF into single Markdown file. If we open the Markdown output, we can see that figures are identified correctly and descriptions are also generated for them. When we compare them with original PDF, they match properly. So the pipeline is doing a solid job of extracting and structuring the content. Overall, I think this document processing method is quite robust and you can use it in your own RAG pipeline. That's it for this video. In the next video, I'll cover the chunking strategy. Until then, take care. Bye.